Hey QE decoders, this is Michael. In the last chapter, we implemented the checker drop game logic with a one-shot prompt. Now, that didn't go so well. Maybe this time, we'll learn our lesson. Our goal is to integrate the game logic into the custom hook used by the game component. So let's take this a little bit more carefully. Before we write the plan, let's chat with our AI assistant. So I've got my tic-tac-toe right here, and I've got my checker drop right here. And I want to switch to ask mode so that we can just discuss what this plan might look like. Okay, so my prompt this time, let's discuss replacing tic-tac-toe TS with checker drop TS in use game TS to implement checker drop PRD MD. So I have put all 4 of those files into context. And here, I am asking it to give me a high-level 3-step plan to complete the task. So I'm constraining it to a very small number of steps. So it's going to have to give me big steps. So when I ask it to do this, then what I'm looking for is how can I break down the problem. So now it's going to say, let's update the game logic and state management. Then, step 2, update the game mechanics and validation. And step 3, update the UI integration and game flow. So, this seems like update game logic and state management is a little bit too small, because a lot of that is already happening inside of compute checker drop state. Okay, so here I'm telling it, let's combine steps 1 and 2. I'm still in the same context, so it's got all that information. Critically analyze the reuse game hook. So I'm using the word critically. I found that this takes it out of that, hey, hyper-friendly, I'm just going to help and preserve all the existing code. No, critically analyze. Take a look at this code and determine the specific changes that will need to be applied to replace tic-tac-toe state with checker drop state. That is our goal, and I want you to be critical. So yeah, looking through those recommended changes, those actually do look like the required changes to make this happen. So I'm actually pretty happy with this. So now let's go to agents. Here is where you can make a choice. You could tell it to just do the thing, or you could tell it to write a plan. I'll say write a plan. I'll say write a plan to apply those changes. Now, when I say write a plan, I am being very terse. However, there is already something in this project that tells it what I mean when I say write a plan. Cursor, rules, documentation structure. Always apply. So this markdown file is going to be loaded into context every time, and this tells it what a plan means. So put it in docs plans, use checkboxes, track progress indicators. So it's producing very consistent plans every time I ask for a plan, and that's because I have that rule in there. And so because of that, it came up with a plan. And it looks like this is right. It even included the testing checklist, and actually now that makes me glad that I went through the planning step, because my cursor rule for plans tells it to create a testing checklist. So this is going to make sure that the tests are either updated or new tests are created. So I've committed that change, and now I'm going to replace my chat. I don't want any of that previous thinking to be in here. Everything that I want it to think about is already encapsulated in this plan. So implement checker drop implementation plan. So let's start by taking a look at the tic-tac-toe board. So we've got this little UI right here. We can step through all the changes, and we can see that it's not a cell click, it's a column click. Yep. And the current player is not XO or observer, it's red, black, or observer. I can see here that this is a completely new user interface. So it's put the letters A through G at the top of the columns, and then it displays the board grid. We'll have to see what that looks like when we run it. That was more than I wanted, but it's not a huge change, so I'll keep it. So now we can quickly scan the plan and we see that it checked all the boxes. The testing checklist is not complete. So we accept all of those changes, and now we can take a look at what this game looks like. Just how has this been updated? I'm kind of curious. So let's start a brand new terminal here, and we will do npm run dev. Let's create a new playground. Then we wait for our player to join us. There's Vincent. Vincent gives us a challenge, so we respond to the challenge. That starts a game, and there we go. We've got a game. The bottom row is at the top. That's kind of funny. Okay, well, let's play the game. Boom. And by the way, the bot that is playing this game thinks it's playing tic-tac-toe. So it's giving alternate moves with 0 through 8 as the indexes in order to fill in a tic-tac-toe grid. And it's not going to repeat an existing move. So it thinks that I played in a particular square, so it's not going to play in that square. So it's really just going to try to fill up the top row. But it's going 0 through 8, so it has a 1 in 9 chance of making an invalid move. In fact, eventually it will make an invalid move. Yeah, it probably just did make an invalid move right there, because now I get to move again. It's still trying to make an invalid move. So I'm just going to fill up column C, and it says, wait a minute, I've filled up all of the slots. There's no valid move for me. I can't win. Let's go back. Let's challenge Vincent. I will start. Send the challenge. Leroy Jenkins versus Vincent. Okay, congratulations, you won. It detected the win condition. So it's got the right game mechanics in the hook. The view is upside down. And of course the view doesn't follow the PRD because I didn't tell it to. It did a little bit more on the view than I wanted it to, but that changed it to a 7x6 grid. Now, the AI player, Vincent in this case, is playing the wrong game. But we will go back and fix those problems. In the meantime, I think this is a good first step. Let's move on to the testing checklist. All right, we are back to just the plan. We're going to Alt plus that thing in order to create a brand new context. And this time we're going to ask it to implement the testing checklist. Okay, so now I'm going to stop it again because it's trying to create some very rigid tests. It's trying to basically test all of the game logic through the hook. So I told it we already have really comprehensive tests for the game logic in checkerdrop.test.ts. I'm bringing that into context so I can read through those tests, see what we've already covered. So don't duplicate those tests, focus only on the hook behavior. So I've stopped it because it's still having a hard time getting those last couple of tests to pass, and that's because it's trying to set up these complex game scenarios. So I'll tell it to copy the game moves from checkerdrop tests in order to set up a win or a draw. That might put it on the right track. Let's see. That seemed to have put it on the right path. Now we've got all the tests passing. Okay, so once it finishes up, tells me what a great job it did, and updates the implementation plan, then we'll review that code and see if it really did a good job. Now this test looks peculiar. Winning moves 0, 1, 2, 3. Red wins horizontally. Where are the black moves? I would expect that you call that thing twice in a row and it's going to give you back success false and say that it's not your turn. Right here. That's interesting. Well, let's ask. So I'm going to switch to ask mode. And so I told it in use game test, should prevent moves when game is over, makes 4 moves in a row. This seems incorrect. Red cannot make 4 moves in a row. Critically review this test and determine if it correctly sets up the scenario. I should be more explicit here. Red cannot make 4 moves in a row without black intervening. Now, again, I used the word critically. I want you to critically analyze this test. So, don't be nice. Tell me what the problem is. Okay, this is interesting. This is a behavior that I've seen with these LLMs. It's not looking at the code, it's using its knowledge of the domain. Okay, so let's read through this. You're absolutely correct. It always starts with that. The test should prevent moves when game is over has a critical flaw. Let me analyze the problematic section. The test uses make move, which is always making a move as the challenger, red player. It makes 4 consecutive moves, all as red. In Connect 4, players must alternate 2 turns and cannot make 4 moves in a row. So right there, its thinking is all about Connect 4. It's not about the use game hook. Yeah, I'm going to continue this conversation and see if it can critically analyze the use game hook to tell me what the expected behavior is. Ignore the actual rules of Connect 4. We don't even have the word Connect 4 in this code. This is checker drop. Okay, I think I understand what's going wrong. It didn't get there, but I think what's happening is that we're calling make move without allowing the render function to do its thing. So it's not creating that fact and then allowing the use specification to update that fact. Let me show you specifically what I think is going wrong. Okay, right here is the make move function. We call this function with a column. It's going to go through this validation logic. And then once it gets here, it's going to create the Janaga fact move with that particular column. All right. On the first call, that's perfect. It does that. However, nothing is waiting for React to then run through a render loop. And so that fact is created, but nothing else happens with it. What should happen with it? Well, up here at the top, we have this moves spec. So this is going to find all of the moves in the game. Where we use this move spec is right down here in this use specification hook. So the use specification hook will cause a re-render because it finds this new move that matches that specification. And so it's going to cause a re-render in which the moves projections, I still need to fix that double plural, in which that array contains that new move. That's what will happen in the actual runtime. Now, during test time, we're not pausing for that to take effect. So therefore, it's going through this code, creating a move fact, and then immediately calling it again. It still has the old state, and it creates another move fact. And so you end up with 4 move facts, all with the same index. It's all moves length is 0. And you have columns 0, 1, 2, and 3. And therefore, when it plays those facts back, it sees all 4 of those are taken up by red. The index is even. It's all 0. And so you've got 4 red checkers in the board, red wins. Now, this is where we need to put a wait for inside of this loop. So it needs to wait for something to be true to tell us that it actually made that move and it got back a new list of moves. So what are we going to use here? I think that would do the trick. So we're going to wait for the number of moves that we get back inside of our move data to be I plus 1. So the first time through, I is 0. It's going to make a move, and now let's wait for this list to have 1 move in it. Now, in order to truly reveal the problem with the test setup, what I want to do is to also expect the error to be null. Now, I believe that if success is true, the error is set to null. The reason I want this to be first is I want it to fail here and show us in the output. I expected null, but I got this error. The error appears in the output, and then that will really direct the LLM to saying, hey, wait a minute, that's not what I expected. There's something wrong, and this is the error that it's returning. I can see here that the type is string or undefined, so let me go ahead and change that to undefined rather than null. It is very picky about that. So I'm going to run this test to see that it does what I expect it to do. And should show correct game state. It expected the error to be undefined, but instead, it's not your turn. Perfect. Perfect, perfect, perfect. So that tells me both of these things happened. That it waited for the move's length to be 1, then it went back through the loop, tried to make a move, and then it actually put the error message in the test results. Now that we have everything set up in order to give the LLM the appropriate context of what it did wrong, now let's point it at the problem, give it a hint, and see what it can come up with. Okay, so I've given it a little bit more than a hint. The test should prevent moves when game is over is failing. It attempts to make multiple moves as the red player without allowing black to move in between. Run the test to see the failure and then give me a few options for correcting the test setup. So I'm specifically telling it to run the test. If I don't tell it that, then it tries to just make a bunch of changes. Run the test first, see the failure, and then give me a few options. Don't just go ahead and make the changes. Now we do have to run this in agent mode because ask can't run the tests. So I am trusting it to give me a few options and not implement any of them. Well, let's see if it's able to stick to the plan. Okay, it's given me 3 options and then asked me, after giving me its recommendation, would I like to implement one of those options? Perfect. Keeping it on the rails. I love it. So it recommends option 1 as the most straightforward fix. Let's see what that option is. All the way back up here. Options for correcting the test setup. Modify the test to properly alternate between red and black players, similar to how the other tests work. So it's, the problem is it has one hook. So it's as if it's playing as one of the 2 players. Let's expand it so we can see a little bit better what it's trying to do. I don't think that it's going to be able to play as the other player using the hook. Now look at this. This is actually kind of interesting. If it's red's turn, then we use the challenger player. If it's not red's turn, then we use the opponent player. We get the current player hash, and then we render the use game with different parameters. Okay. So now it actually is able to swap from one side to the other. This just might work. Now, of course, this move sequence is incorrect, but this looks like it might be a good way to resolve things. So option 2, use a different winning sequence. Now it's got the correct winning sequence, and it's still doing the render use game change. Okay. I think actually option 2 is the correct way to go. So let's implement option 2. Rerun the test, and the test passed. Okay. That's good stuff. Excellent. Let's run all of the tests and see if there's anything wrong. I didn't ask it to do that. It probably should have stopped at this point, but it's going to go forward and run all the tests. Okay. Test pass. The custom hook is properly integrated with the game logic, and now the tests are all pausing to allow the React update cycle to complete. It's looking good for finalizing the UI and updating the player sim. So coming back for the final chapter of Build Your Own Game, AI Assisted Development, and we will finish out the UI. So I'll see you then.